Okay, so we are having this topic in physics uh, called force. So without wasting much of our time, I'm your tutor, Witness Mudenda, and welcome to my online lessons in physics. Okay, so we have to define what force is, and by definition of force, we can easily, without any complications, say this is the pull, or rather, you can say the push. This is the push or pull. Okay, this is the push or pull of an object. This is the push or pull of an object, or rather of object, causing it to change the velocity. Causing it to change the velocity. Okay, others would just say this is the push or pull of gravity. This is the push or pull of gravity. That is what others might say, but it is still the same. Okay, types of forces. Okay, so we also have types of forces. Uh, we have types of forces which are classified into two major categories. We have what we call contact force and non-contact force. Okay, contact force and non-contact force. But I will not explain them, or rather teach them in terms of their categories. But rather, I'll just go direct to the major types of force. Okay, we have number one. We have what we call weight. Okay, we have what we call weight. So someone may ask a question that what is weight? Okay, so we are saying weight. This is the gravitational force acting on an object. It acts vertically downwards through the center of gravity. Okay, we shall talk about gravity later on. Maybe rather gravity, it's just the force of the ground, so to say. Okay, so we're saying weight. This is this is not saying. This is the gravitational force. This is the gravitational force. Gravitational force acting on an object. Okay, that is what we mean by weight. That is what we mean by weight as the first type of force. Okay. So the other type of force that we can talk about the second type of force that we talk about, number two, it is the reactional force. Okay, this is the reactional force. Actually, it's reaction force. Okay, so what is this reaction force? What is this reaction force? When a force is exerted on a body, there will be exert an equal and opposite reaction. So we are saying that this is an opposite. This is an opposite reaction of a force. This is an opposite reaction of a force exerted on a body. This is an opposite reaction of a force exerted on the body. Exerted on the body. Okay. I remember the typical example of this reaction force that I was given when I was still in high school. They gave us an example that when you hit, for example, the wall, the pain that you are going to feel, it is equal to the energy or rather the force that you applied on the wall. That is the typical example of the reaction of force. That is the typical example of reaction of force. So, number 3. Okay? Number 3, we can talk about tension. Okay? Talk about tension force. Okay. What is tension? This is the inward force exerted by bodies under stretch. This is the inward force. This is the inward force exerted. Okay? Others would say exerted, but it depends, provided the spelling is the same. Exerted on an object, or rather the body. On an object or rather the body. On an object or rather the body. Under stretch. Under stretch. Under stretch. Okay. So that is what we mean by tension force. Okay. So I'm just listing down the types of force. Bear in mind that we are just listing down there and trying to give them some simple definitions without typical explanations of each type of force that I've listed down here. Okay, so we also have to look at compression. Okay, compression, okay, force. So compression force is also a type of force where the outward force is exerted by bodies under compression. So this is just more like the opposite of tension. With tension, we say this is the inward force exerted on an object or body under stretch. Okay? On the other hand, when we talk about compression, we are just talking about the outward, not inward, the outward force exerted by bodies under compression. Okay, this one, the body was stretched, but under compression, the body will be what? Will be compressed. That is totally the opposite of each other. Okay, so we'll say this is an outward. This is an outward. Okay, this is an outward force exerted by bodies. Create some more space up there. Okay. Created by bodies. Created by bodies under compression. Under compression. Okay, so we can give a typical example of rather a spring where when you stretch, well, I mean when you compress it. Okay, when you compress a spring, or rather when a body compresses a spring, we can say that that is the body which is called compression, because we will see a spring being compressed by yourself, or rather any other body which can compress the spring. I'm sure now I'm going on the fifth one. The fifth type of uh, force is called thrust. Okay, thrust. Okay. So what is thrust? This is the type of force exerted by displaced fluids. Okay, exerted by displaced fluids, e.g., we are what we call upthrust, which is equal to the weight of the displaced fluid. Okay, so we are saying thrust is the force exerted by displaced fluids. For example, we have what we call upthrust, which is equal to the weight of the displaced fluid. So we say this is the force. This is the force. This is the force exerted. Or rather, instead of it use exerted, you can say applied. Okay? Applied. This is the force exerted, or rather applied by or displaced by fluid. Sorry. Applied, exerted, or rather applied by displaced. Displacing fluids. In simpler terms. So we are listing down the types of force and also giving them a little explanation of it. We are not explaining these examples in their typical way because, for example, weight. Weight can be a topic on its own, but in this case, we are just listing it as one of the. It's a topic on its own which can be calculated, but in this case, we're just listing it as one of the types of force. Okay, I don't think I'll be able to list down all the types of forces because there are as many as 10. I don't know. They are many, but I'll not go as much as that. I think let me just talk about this last as the last one, which is gravitational force. So gravitational force. So this is a type of force as well, and we are saying gravitational force. This is the force of attraction between two bodies, which is directly proportional to the product of their masses and inversely proportional to their square of their distance of separation. Okay, so to break this down, we can easily say a gravitational force is the force of attraction between two bodies. Gravitational force, this is the force. This is the force of attraction. Force of attraction. This is the force of attraction, okay, between two bodies. This is the force of attraction between two bodies. Okay, so there are so many stuff to talk about on force. We'll not only sit and talk about that, we'll talk about the types of force. Okay, so we also have to know that force has got what we call the SI units. Okay, so the SI units, the SI units of force, the SI units of force is newtons. Okay, it's Newton. Those are the SI units for force. The SI units for force is Newton. Okay, so we are able to see that force, it is calculated using this formula which we have here. Force is calculated using this, where, okay, where F equals force, M, okay, we say force in newtons, Newton, then mass, M equals mass, okay, in kg, mass in kg, and A, acceleration, okay, acceleration in meters per second squared or in Newton per kg. In meters per second squared or, okay, my chalks are finishing now, or in kg, in Newton, sorry, per kg. So acceleration is measured in meters per second squared or Newton per kg. Okay. So we have to look at a few examples. Okay. We have to look at a few examples. Yes, these jokes are finished. Okay. Examples. So these few examples we look at, we'll also try to give them solutions by quite right solving them. Okay, examples. Number one. Okay. Number one, we'll say what force is needed to cause a train of mass? What force is needed to cause a train train of, that is 500,000 kg, 500 kg to accelerate at 0.04 meters. Sorry, I have to write this here. 0.04 meters per second squared. Okay. So question two will say, or maybe before we look at question 2, I have to give the solution to that. So the formula for force, it is F equals MA. Okay, MA. We already know that F is the force, M is the mass, and A is the acceleration. Okay, so then how do we go about this? We're going to say force. The question is saying what force? So we want to find force. So we easily say force equals, what is the mass? The mass has been given in the question, and the SI units for mass, it's kg. So we'll say that is 500, okay, 500,000, we multiplied by the acceleration which you have been given, which is 0.04. Okay, which is 0.04. That is 0.04. So what will be the answer there? I have to give you some time. What will be the answer here? So you find that when you multiply these two, in mathematics, I haven't yet uploaded my video that I have to teach about how you go about a multiplication of decimal numbers and also numbers with such zeros. There's a certain logic that we use there. It's very simple, but in this case, we just have to calculate it directly by saying 500,000 times 0.04. What answer is it giving us? Okay, that is a 20,000. Okay, so if at all by mistake you let the answer in an exam like that, other markers will mark it wrong, but others might. Okay, others might, but just like I earlier stated that the SI units of force, it's Newton, and Newton is denoted by capital letter N. So that is our answer. We say 20,000 Newton. Okay. Quickly look at the second example as we are winding up our today's lesson. Okay. As we are winding up our today's lesson. Okay. Example 2. A 900, or maybe you only look at that example, an electrical railway, locomotion of mass, an electrical railway. Railway locomotion. An electrical railway locomotive of mass 50,000. Locomotion, but locomotive of mass 50 1,000, 50,000 kg starts from rest. Kg starts from rest. Okay. Starts from rest, and after 20 starts from rest and after 20 seconds. Yeah. Okay. And after 20 seconds. So the question continues to say it has accelerated to a velocity of, it has accelerated to a velocity of 25, the velocity of 25 meters per second. Okay? Calculate, full stop here. Then say calculate A, the acceleration of the locomotive, yeah. Calculate the acceleration of the locomotive acceleration of the locomotive. B, the horizontal driving force horizontal, that's horizontal, the horizontal driving, the horizontal driving force and finally okay, horizontal locomotive force, and finally we'll say as C. Okay, C will also say the distance traveled in 20 seconds. The distance traveled, in 20 seconds. In 20 seconds. Okay. Solutions. Solutions. Okay. So question C is saying the distance traveled in 20 seconds. In 20 seconds. Okay. So solutions. A. Okay. So an electrical railway locomotive of mass 50,000 kg starts from rest, and after 20 seconds, it has accelerated to a velocity of 25 meters per second. Calculate the acceleration of the locomotive. Okay, the acceleration of the locomotive. Now, in this case, we know that the formula force is equal to mass times acceleration. So, what do? We know that we are finding mass. So it means an electrical railway. Okay, just a minute, just a minute, just a minute. Okay, okay. So we know that the formula for calculating force, uh, the formula for calculating force is this one that we have been given on the board, which is force equals mass times acceleration. Unfortunately, when we have been given such questions in an exam, most of us what we do, or rather most of you as pupils what you do, is to use this very formula because there's also acceleration. And then after that, you use that substitution method option. At the end of the day, the answer becomes wrong. So since you have been asked to calculate acceleration here, we'll definitely go straight away to use the formula for acceleration. Okay, acceleration is equal to v as the final velocity minus u as the initial velocity over the time that you have been given. Acceleration equals v, which is the final velocity. Okay, the final velocity, it is the velocity which is usually given in the question after an object accelerates. So in this question, our question, in this situation, the question is saying an electrical railway locomotive of mass 50,000 kg starts from rest. Rest, that is the initial velocity, which is the u there. And after 20 seconds, that's 20 seconds, it's the time. Okay? And then it has accelerated, which means from 0, it now accelerated going to what? It accelerated going to the velocity of 25 meters per second. That is now what we call the final velocity. Therefore, acceleration is equal to 25 minus 0. When an object it is on at rest, which means it's not moving. Therefore, the acceleration, or rather the velocity, I mean, it is at 0 over what is there? The time that was 20. Acceleration equals, that is 25 over 20. Okay. This is equal to, that is mathematical scholars. So acceleration is equal to, that is the 1.25. Now, acceleration. Acceleration, I said earlier that it is calculated in meters per second squared, or rather in Newton per kg. Now, in this case, we are going to say that is 1.5 meters per second squared. That is our acceleration. Okay, so going to B. B, it is saying the horizontal driving force. What was the horizontal driving force? Okay, so in short, we are just finding the force here. So I'm going to say force equals MA, mass times acceleration. Then we will say force equals, what is the mass? The mass has been given the question, that is 50,000 kg. Okay, 50,000 times the acceleration is the one that we found here on the calculating. That is 1.25. Okay, so what would our next step is to multiply 50,000 times 1.25. Okay, so force because 50,000 times 1.25. So this is what we got here on the acceleration. That is 62,500. Force, it is calculated in Newton. 62,500. That is our force. Newtons. C. Let me clear up some space. Okay. So C, it was saying the distance, I think, yeah, the distance traveled in 20 seconds. Distance equals mass. Distance equals mass, okay, times, just a minute, okay, okay, so sorry for that inconvenience. Okay, so when calculating speed, sorry, not speed, when calculating the distance, we are not going to say distance equals mass, but the formula for calculating distance is this speed times time. Okay, speed is the speed times time is the formula for calculating distance. Therefore, say distance equals, looking at the question you have been given, that final velocity, it is the speed that we are going to use here, which is 25 meters per second. So it's 25 times the time that we have been given in question C, it is 20, that is 20 seconds. So say distance equals 25 times 20, it's 500. Okay, so distance, it has got some SI units. It has got some SI units of meters per second. So this marks the end of our today's lesson. And thank you very much. May you subscribe to my YouTube channel and also share, please. Share, and share. Thank you. See you in the next lesson.